This one, it just says to simplify each, state any excluded values. So I'm going to start with the excluded values. To get the excluded values, we set the denominator equal to 0. And we solve. Here I can factor out a 5x, which leaves me with an x squared minus 2. And now I set each factor equal to 0, so 5x equals 0. The x squared minus 2 equals 0. And I solve each. This one I divide each side by the 5. So I find out that x equals 0. Or rather, x cannot equal 0. Here I add the 2 to each side. So I find out that x squared equals a 2. And then I take the square root of each side. And when I do this, I'm just going to plug this into my calculator and express it as a decimal, just to round it off. So the square root of 2 is, and since we took the square root of each side, it's got to be plus or minus the 1.41. So these are all my excluded values. And now from here, I'm just going to simplify this as far as I can. So I'm going to factor this. 5x squared, that can't be factored. The denominator already factored once. I factored out of 5x. And now from here, the 5's cancel. The x squared and the x cancel and leave me with just an x in my numerator. So this reduces to an x over x squared minus 2. But I have to say that x cannot equal a 0 or a plus or minus 1.14. And so my solution with the excluded values is this. And that's it. Okay? If I do the same thing for the next one, again, set the denominator equal to 0. These are my restrictions, the excluded values. I build a bridge. I can factor this into an x minus 4 and an x plus 2. Again, I set each factor equal to 0, so x minus 4 cannot equal 0, x plus 2 cannot equal 0, and I solve each. I add the 4 to each side. Over here, I subtract the 2 from each side, so I found out that x cannot equal a 4, and x cannot equal a negative 2. And now from here, I have to simplify or reduce my fraction. I'm just going to factor it. The numerator factors into an x minus 4 and an x minus 5. The denominator, I already decided, factors into an x minus 4 and an x plus 2. And now I cancel out any common factors. The x minus 4's cancel. So I'm left with an x minus 5 over x plus 2 with the restrictions of x cannot equal a negative 2 or a positive 4. And that's it. Okay. Number 20, again, is very similar to this. Let me section that off. The first thing I do is I set the denominator equal to 0. So 5 minus x cannot equal 0. And I solve this for x. The easiest way to solve this one for x is just to add the x to each side. And so I have 5 cannot equal x, or rather x cannot equal 5. That's my only restriction. And now I'm just going to simplify this by factoring. The numerator, that's a difference of squares, factors into x plus 5 and x minus 5. The denominator, I'm going to rewrite as a negative x plus 5. And we can see that kind of looks like what I have in my numerator, but not quite. Think of it this way. If I factor out a negative 1 out of that, that's going to leave me with an x minus 5. And now I can see that the x minus 5's cancel. So I'm left with x plus 1 over a negative 1. Well, if I divide, that's just a negative x minus 5. So that's my simplified version with the restriction that x cannot equal 5. And that's it. Okay? In the next one, I'm just multiplying. And remember, when I multiply, I want to factor everything completely. Here, x plus 6 doesn't really factor. The 4x doesn't really factor. The 8x doesn't really factor. So everything here is factored. So now I just reduce. The 8 and the 4 reduce to a 2 and a 1. The x's can cancel out. And that's it. So in my numerator, I'm left with a 2 times x plus 6. In the denominator, I'm just left with an x plus 1. And that's it. And number 14, again, I'm going to start off by factoring everything completely. This numerator factors to an a y minus 3 and a y plus 2. The denominator is already factored as far as it can be, a 3 times y. Numerator over here is already factored, and denominator over here is already factored. Now I cancel out any common factors. The y plus 2's cancel out. The y's over here cancel out, and the 6 and the 3 reduce to a 2 and a 1. So now in my numerator, I'm left with a 2 and a y minus 3. In the denominator, I'm not left with anything. So when things cancel out through division, it means I'm left with a 1, which means I just have 2 times y minus 3. And that's it. All right, at number 15, we want to essentially do the same thing. We just have to remember that this thing is over 1, so it still is a fraction. Now we're going to factor everything completely. The a plus 1 can't be factored. The 2a minus 2, I can factor a 2 out. For this guy, the 8a squared minus 4, I can factor a 4 out, which leaves me with a 2a squared minus 1. And really, this is all I can do in the way of factoring. So now I'm just going to cross out what I can. The 2 and the 4 cancel out, reduce to a 2 and a 1. And it looks like nothing else is going to cancel here. So what I'm left with is a 2a squared minus 1, and an a plus 1 in my numerator. And then in the denominator, I'm left with an a minus 1. And that's it. That's as far as I can take this thing. Okay? For this one, we have division. Again, this whole thing is like over 1, but dividing, I'm going to change to multiplying by the reciprocal. So instead of dividing by this value, I'm going to multiply by 1 over the x squared plus x minus 12. And now I'm just going to simplify this by factoring everything completely. Here I have a difference of squares, factors into an x plus 3 and an x minus 3. The x plus 4 is already as simplified as it can be simplified. Down here I build a bridge, I factor it, becomes an x plus 4 and an x minus 3. And now I cancel out any common factors. Here the x minus 3's cancel, and that's it. So my numerator is the x plus 3. Again, my denominator is x plus 4 and x plus 4, which I can rewrite as x plus 4 squared just to save a little space. Okay? For the next one, again, this is division. Think of this middle fraction bar as a division bar. Remember, a division bar and a fraction bar are the same thing. So I'm still going to change it to multiplying by the reciprocal. So this first fraction stays the same. The second fraction I change to multiplying by an x squared plus 9x plus 20 over an x squared minus 4x minus 12. Okay, now I factor everything completely. This first numerator factors into an x plus 2 times an x plus 2. Denominator stays exactly the way it is. Over here, this factors into an x plus 4 and an x plus 5. The denominator factors into an x minus 6 and an x plus 2. And now I cancel out any common factors. The x plus 5's cancel. These x plus 2's cancel. So now in my numerator, I'm left with an x plus 2 times an x plus 4. And in the denominator, I'm left with an x minus 6. And that's it. And number 18, because we have a polynomial divided by a monomial, I'm just going to divide each piece. I'm going to do the 12y to the 8th divided by the 4y squared. And then I'm going to do the plus 20y to the 3rd divided by the 4y squared as well. Okay, so I'm just using my distributive property. I divide each. This first one leaves me with a 3y to the 6th. This next one leaves me with a 5y. And that's it. That's all we have to do for these. Okay? The next one, number 19, I have to get common denominators, and I already have common denominators here. So I'm just going to subtract the numerators. Remember, that's the same as adding the opposite. So when I add these, that's a 3x plus 6. Denominator stays the same. That's an x minus 2. And that's not quite it. I suppose the one thing I do need to check here is I need to check to see if I can factor this at all. Here I can factor out a 3, which leaves me with an x plus 2. Which doesn't really help me. Nothing cancels out. So I can either leave my answer the way it was or write it as the 3x plus 2 over the x minus 2. Okay. For the next one, I do not have common denominators here. And remember, I need to have the same factors for each. So for this one, right now, the first fraction, it needs the x, the 2x minus 1. The second fraction needs the x plus 3. And now they'll have the same factors. Okay, they'll each have a 2x minus 1 and an x plus 3. And really, we can just think of this as multiplication. And it's the same thing here. I'm going to multiply these, which means I'm distributing the 5. I'm going to multiply these, which means I'm distributing the 4. So that gives me a 10x minus 5 over the 2x minus 1 x plus 3. And notice I leave the denominator factored. It makes the most sense to do that, to leave it that way for now. And now from here I can subtract. Remember, subtracting is the same as adding the opposite. And so when I do that, that gives me a 6x, and it looks like a minus 17. And that numerator is not going to factor at all, so I'm just going to leave it the way it is, which means nothing else is going to cancel, which means this is my answer. Okay? For the next one, again, very similar to the one we just did. Right now, it doesn't appear that they have anything in common. So I just need to give each of these what the other one has. So right now, the first fraction needs the x plus 4, so I'm going to multiply by x plus 4 over x plus 4. The second fraction needs the x minus 7, so I multiply by x minus 7 over x minus 7. And when I do this, this one's a little bit trickier because if I look, I've got two binomials here, which means I have to FOIL or distribute when I do this. So that's going to give me an x squared plus x plus 4x plus 4, which of course simplifies into an x squared plus 5x plus 4. I'm just going to do that right here. I would recommend taking that off to the side to do it if you're unsure. Here I'm going to FOIL this out. That's going to give me an x squared minus 7x minus x plus 7, which then when I combine those middle terms is going to be an x squared minus 8x plus 7. Again, the denominator is the x plus 4 and the x minus 7. And now I can add those numerators. That's going to give me a 2x squared, a minus 3x, and a plus 11, all over the x plus 4, x minus 7. And the last thing I can do is check to see if this thing's going to factor, build a bridge. I get a 22. I can't find two numbers that multiply to 22 but add to a negative 3. So I'm just going to leave this one the way it is. Okay, so get your common denominators and then see if the thing simplifies. And then this last one, it says a board of length 6 over x minus 5 meters was cut into two pieces. If one piece is 5 over x plus 5 meters, express the length of the other board in meters as a rational expression. So the overall length of the board was the 6 over x minus 5. That's how long the board was. I cut it into two pieces. So in other words, I took one piece away. I subtracted a piece from that board, which was represented by the 5 over x plus 5. Okay, so now this is just a subtraction problem. I need common denominators. Here I've got to multiply this by the x plus 5 over x plus 5. This one, the x minus 5 over x minus 5. Again, just give each denominator what the other one has. So here I'm going to distribute. Here I'm also going to distribute. That's going to be a 6x plus 30 over the x plus 5x minus 5. Here that's going to be 5x minus 25 over the x plus 5, x minus 5. And now I can subtract, which is the same as adding the opposite. So that's going to give me an x and a plus 55 all over x plus 5, x minus 5. And that's it. It doesn't reduce, it doesn't simplify after that. Hope this was helpful, and good luck on your test.